Now if we were to look at this graph, we would be able to find the local maximums and local minimums. So we would be going through, well, this point right here, we're going to call that point 1, could be a local minimum. And if you look at the notation a, f of a, remember f of x is the same thing as y. So when we're dealing with an x coordinate that's a, that means that the y is going to be f of a. So that's no different than saying that this point, x and y, fancy notation. If we keep going, we'll call this point 2. Point 2 is going to be a local minimum according to our maximum, according to our definition. So u, f of u, and this is what we know. If we keep moving right along, point 3 would be what we would consider a local minimum, and point 4 would be a local maximum. Now, if we take this one step further, if we look at this graph, if we want to find out what the absolute highest point that this graph will ever touch, we would call that point 2. So more specifically, it is not a local maximum, it is called an absolute maximum, because that is the absolute highest that this graph will ever go. There's no arrows on here to make it go up to infinity. Same way, we could call our local min of point 3 down here, we could call this not a local minimum, but an absolute minimum, because that is the absolute lowest that this graph will ever touch. There is nothing that will happen below this graph. So yes, a graph can have both absolute and local minimums and maximums. Does not mean it has to have absolute maximums or minimums. If you think of something like, if we make up a graph, let's do a graph like this, because it goes to negative infinity and positive infinity, it would only have a local maximum here and a local minimum here, no absolutes.